Welcome guys to my YouTube channel Vision's Mindful Moments. So today, especially this video, I have prepared for the students of class 12 arts as well as those who are having the subjects statistics. They also will be benefited from this video. So in this video, I am going to calculate quartile deviation from group data. Okay, from a frequency distribution table, how to calculate quartile deviation that I am going to do today in this video. So okay, let's take a frequency distribution table. Okay, quartile deviation. Okay, this is quartile deviation. Let's take a frequency distribution table. So here class intervals. Class intervals. So suppose 85 to 89, 82, 84, 75 to 79, 72, 74, 65 to 69, 60 to 64, then 55 to 59, and 50 to 54. Okay. So the frequencies are given 3, 7, 10, 8, 12, then again 10, 6, and 4. And n equal to given, that is 60. So okay students, suppose it is given, it's a frequency distribution table, and now you are to calculate quartile deviation from this table. So how to calculate? So first of all, you should know the formula. So what is the formula of quartile deviation? Let's write here. Q equal to Q3 minus Q1 divided by 2. Again, Q1 equal to L plus N by 4 minus CF divided by FQ into I. So another formula is there. Q3 equal to L plus 3N by 4 minus CF divided by FQ into I. So these are the three formulas you are to apply to calculate quartile deviation. So Q equal to Q3 minus Q1 divided by 2. This is the main formula. So here Q3 minus Q1 divided by 2. So Q3, you have to calculate Q3 also. So this is the formula of Q3. Minus Q1, this is the formula of Q1. So after finding out first quartile, that is Q1, as well as third quartile, that is Q3, then you have to put in the main formula and divide by 2, then you will get quartile deviation. So these are the three formulas you have to apply. So here, suppose first we will calculate first quartile or third quartile. So for that purpose, the frequency distribution table, already class intervals and frequencies are there. So one more column you have to prepare, what we call CF column. CF. CF means cumulative frequencies. So this column you have to prepare. After that only you can find out first quartile, third quartile, then quartile deviation. So how to calculate CF? Cumulative frequencies, how to calculate? So first what we have to do, the frequency of the smallest class interval you are to put in the CF column as it is. So these are the class intervals. So 50 to 54, this is the smallest one, and 85 to 89, this is the largest one. So smallest class interval 50 to 54, so the frequency is 4. So we have to put the 4 as it is in the CF column. Okay. Next frequency is 6. You have to add 4 with the 6. After adding, you will get 6 plus 4, that is 10. Then again, after 6, the third frequency is there, 10. So you have to add 10 with this one. That is 10 plus 10, 20. Then next one, 12. 12 plus 20, 32. 32, next one is 8. 8 plus 32, you will get 40. 40 plus 10, you will get 50. 50 plus 7, 57. And 57 plus 3, that is 60. Okay. Did you understand this? How to calculate the cumulative frequencies? So first of all, what to do? The frequency of the smallest class intervals. It may be at the bottom, it may be at the top. The smallest one sometimes may be in the top, sometimes may be in the bottom. So here it is at the bottom, the smallest class interval. And the frequency of the smallest class interval is 4. So you have to put this 4 as it is in the CF column. Whatever is there. It may be 1, it may be 2, it may be 3. So as it is, 4 is there. So we put here 4. And the next one is 6. You have to add this 4 with the 6, next one. So 6 plus 4, 10. Again, after that 10 is there. So 10 plus 10. In that way, so this is the actually 4 plus 6, 10, 10 plus 10, 20, 20 plus 12, 32, 32 plus 8, 40, 40 plus 10, 50, 50 plus 7, 57, and 57 plus 3, 60. So this is the way how to calculate CF column. Okay. So after getting this, now you go to the formula. So come to the first quartile, that is Q1. Q1. So let's first calculate first quartile, that is Q1. So what is the formula? That is L plus N by 4 minus CF divided by FQ into I. So this is the formula. So here first we have to calculate, find out L, then we have to find out N by 4, CF, FQ, I. After getting all the values, then we will put in the formula. Automatically we will be able to find out the first quartile. So here direct right hand side, here also you can write here. So first out of all these L, FQ, N by 4, CF, I, first of all you have to calculate N by 4 because N is already given. That's why N by 4 first of all you have to calculate. So N by 4 equal to N is given 60, 60 by 4. So you divide 60 by 4, 15. Okay. So N by 4 is 15. Next you come to the L. L means lower limit. Lower limit. So how to find out this L, lower limit? For that purpose, we have to see the N by 4 is 15. In the CF column, you have to see on which number the 15 number is lying. That means 4, it is still not 15. Then 10, still not 15. Then 20. So it is more than 15. So ultimately, the number 15, it is lying in this class interval. Is not it? That is 60 to 64. In this class interval, the number 15 is lying. So this will be the first quartile series. You can put mark here like this by wood pencil. Okay, by wood pencil you can mark like one. So L is lower limit means 60, but 60 is exactly not 60 because here the series are not continuous. Discontinuous series are there. First of all 50 to 54, then 55 to 59. So 54, then 55. So ultimately there is a gap of 1. That's why 60 is exactly not 60. The exact lower limit will be, you have to deduct 0.5 from 60. 0.5, if you deduct from 60, you will get 59.5. Are you getting? So how we calculated L? After getting N by 4 in the CF column, from the starting point, we started from here. Is not it? From bottom we started in this way. So from the starting point, you have to see on which number you can get 15 or 15 is lying. So 4, it is not 15. Then 10, still it is not 15. Then 20. Ultimately 15 number is lying on this number. That's why this is our first quartile series. So in the first quartile series, what is the lower limit? That is 60. So L actually it should be 60. But we can't take 60 exactly as a 60. Why? Because there is a gap of 1. Because 50 to 54, then 55 to 59. So 54, after 54, it is 55. There is a gap of 1. So to minimize that one, we will deduct 0.5 from the lower limit. So if you deduct 0.5 from 60, you will get 59.5. Okay. But one thing you should know that whenever sometimes it is seen that the class intervals are in continuous series. For example, 50 to 55, 55 to 60, 60 to 65, there is a continuous series. So whenever the class intervals are in continuous, then you need not to deduct 0.5 from the lower limit. Directly, you can take 60. Okay. When you can take 60, whenever there will be continuous series, that is 52, it is not 54, it will be 55. Again, 55 to 60. Again, 60 to 65. So no gap will be there. That's why you need not to take or you need not to deduct 0.5 from the lower limit. Directly you can take. But here the case is different because 50 to 54, then again it is not 54, it is 55. Or you can say it is 52, it should be 55, but not it is 55, it is 54. There is a gap of 1, 54 and 55. So to minimize the gap, we deducted 0.5. So if we deduct 0.5 from 60, you will get 59.5. Are you getting now? Okay. So after getting L, then you find out CF. cumulative frequencies. So cumulative frequencies, what is there? So the first quartile series we are calculating, and first quartile series is in our hand, is not it? So here CF means cumulative frequencies, so we have to say in the cumulative frequencies column. But which one? Just prior to the first quartile series. Cumulative frequencies just prior to the particle first quartile series. So we started from here. This is our starting point. In this way we started, is not it? So just prior to, it indicates 10. This is 32. Yeah, just after, and just before 20, that is 10. Because we started from here. This is our starting point. Are you getting my point? So first quartile series particle is already in our hand. So the score, the number or the cumulative frequency which comes just prior to the first quartile series, that is 10. So 10 will be the CF. Then you come FQ. So what is FQ? Frequency of the quartile series. So this is our first quartile series and frequency is 10. 10. And I means interval. So 50 to 54, 55 to 59. In each of the class interval, what is the interval? How much? So it is 50 to 54, that is interval is 5. Okay. So now all the values in our hand, just put in the formula. So L is 59.5 plus n by 4, that is 15, minus CF, that is 10, divided by FQ, it is again 10, into I is 5. Okay. Next, 59.5, keep it as it is. If you deduct 10 from 15, you will get 5. 5 by 10 into 5. Again 59.5 plus, so 5 into 5. So 5, if you multiply with 5, that you will get 25 divided by 10. So 59.5, 25 divided by 10. You can what you call cut it to make it a small number. So by 5 it will be 2, and by 5 it will be 5. So it will be 5 by 2. So 59.5 plus, if you divide 5 by 2, you will get 2.5. Now you add. So how to add? 59.5 here, 59.5, then 2.5, 2.5. 5, 5, 10, 0 will come, 0.1 is there. So 2 and 1, 3, 9 and 3, 12. So 2 will come, 1, 62. So we will get 62 approx. Okay. So now let's calculate third quartile, that is Q3. Q3 equal to, again the formula already you know. So here we wrote the formula, is not it? Q3 equal to L plus. So here you write L plus 3n by 4 minus CF divided by FQ into I. So this is the formula. Again, like previous one, here you write here. So there we first calculated n by 4. So here you have to calculate 3n by 4. So 3n by 4, that is 3 into n is given 60 divided by 4. So here 4 into 4, 60. If you make it a small one, so here 15. So 3 into 15, that is 45. Okay. Okay. After getting 3n by 4, next what you call, we have to calculate L, that is lower limit. So again you have to go to the particle frequency distribution table. So here 3n by 4, 45. In the cumulative frequency column, you are to see where the number 45 is lying. Again, from the starting point, we will start 4, 10, 20, 32. Still it is not 45. Then 40, still not 45. Then 50. So 45 we got in this number. In this number, 45 is lying. So it will be the third quartile series. So you can put mark like me with the help of wood pencil. Okay, and you can write here Q3. So this is our third quartile series. So from here, all of the values we have to calculate. Okay. So what will be the L? So L means that is 75 is there, lower limit. So as I say that directly 75 we can't take because it is discontinuous series. There is a gap of 1. That's why we will deduct 0.5 from 75. So if you deduct 0.5 from 75, you will get 74.5. Okay. Then you come to the CF, cumulative frequencies. So here in the frequency distribution table, that like previous one I said, so CF means cumulative frequency just prior to the third quartile series. So we started from here. This is our the particular starting point. So this is our third quartile series. Just prior to the third quartile series, what is the cumulative frequency? That is 40. So again you see here, CF means cumulative frequency just prior to the third quartile series. So this is our third quartile series just prior to the this one 40. It is not prior to that, it is just after, it is just before. So you can also say the cumulative frequency just before third quartile series, so that is 40. Okay, then you come FQ, frequency of the quartile series. So frequency of the quartile series, that is again here it is 10, and I means interval. So the same interval is there. There also we took 5. So here also it is 5. Again, same thing is there. Now we put in the formula. So L, it is 74.5. Okay. Plus 3n by 4, 45. Minus CF, that is 40. Divided by FQ, that is 10. Into I, that is 5. So 74.5 plus, if you deduct 40 from 45, again you will get 5. 5 by 10 into 5. So 74.5 plus, here you multiply 5 with 5, you will get 25 by 10. So 74.5 plus 25 divided by 10. If you divide, or you can say, you can cut it to the smallest number. So by 5, 5 2s are 10. Here it will be 2, 5, 5 5s are 2. So it will be 5 by 2. So 74.5 plus, if you divide 5 by 2, you will get 2.5. So you add 74.5 and 2.5, then you will get, so let's add here 74.5, 2.5, 10, 1, so 7 point will come, then 7. So it is 77 approx. Okay, this is the way how to calculate third quartile. Actually, the method is same. The method of calculating first quartile as well as third quartile, same. Only first quartile series and third quartile series that differs. But exact the same process I applied here to calculate first quartile and third quartile. So after getting these two, so earlier what we already wrote here, the main formula, quartile deviation equal to Q3 minus Q1 divided by 2. Now Q3, that is 77, and Q1, that is 62 in our hand. Now we can put in the formula. So let's put in the formula. So Q equal to Q3 minus Q1 divided by 2. So what was Q3? Here you see, Q3 was 77 and Q1 was 62. So 77 minus 62 divided by 2. So what will come here? 70. If you deduct 62 from 77, you will get 15 divided by 2. If you divide 15 by 2, you will get 7.5. So this is the main answer. Approximately, or approx, you can write here. So this is our quartile deviation of the given frequency distribution table. Okay, so very easy one. Just calculation that will be long one, lengthy one, but the same process, same method you have to apply. So first, either first quartile or third quartile, anyone you can calculate, but you have to calculate both. After getting these two, you have to put the values in the main formula, what is called quartile deviation. That is the main formula, Q3 minus Q1 divided by 2. So in this way, we can calculate it. Very easy one. If you don't understand, you can comment me. Okay, you can ask any question in the comment section. But don't forget to share it, like it, okay, and subscribe it, so that you can get the notification for the next videos. Okay, so for today, thank you.